Assalamu alaikum. Welcome to the third lecture of Introduction to Programming. So the topic today is the data types, and we are going to look into what kind of data types are used in order to store data and manipulate data. Whenever you're writing a program, whether it's in Java or in any other language, you need to uh, put data uh, into memory, and then you manipulate that data to get the desired output. So in this lecture, we are going to see how that data can be stored in a computer and how can that data be used by that computer. So moving forward, so what actually is data? So a computer program works by manipulating data, as we just said, but it needs to know what kind of data it is processing. What this means is that whether the data is an integer, whether data is a character value, whether data is a name of some object. So the computer needs to know that. Then the computer performs a set of operations on that data to get some meaningful result. And if the data that is being entered is wrong, so the results will also come out to be wrong. So whenever you are talking about computers and you are talking about data, you have to understand how the computer stores data. So you might have heard about byte, the term byte, megabyte, gigabyte, terabyte. So we need to understand like what a byte actually is. So in a computer there are a lot of circuits, and the processor of a computer is made up of billions of circuits, and these are called transistors. So a transistor is a tiny switch that is activated by the electronic signals it receives. And if the transistor is receiving a signal, so it is considered to be in an on state, and if it doesn't receive a signal, it is considered to be in an off state. So if the transistor is in the on state, we call it the value 1, and if it is in the off state, we give it the value 0. So this 0 and 1 is called the bit value. So if a transistor is holding any value, so the value can either be 0 or 1. And so this is called the bit value. So if somebody asks you that what is the bit value at the moment, so it can either be 0 or 1. Now if we have a collection of 8 such bits, we call that collection a byte. So we have about 8 transistors which are working together to store 1 byte of information. What this means is that all of these 8 transistors, they have either the value 0 and 1, and that value 0 and 1 uh, holds some meaning, and that is how we translate the data which is stored in the computer into meaningful values. Now we will look into the byte representation, but in order to understand that, we will have to begin from the very first bit. A byte is made up of 8 bits, and we look at the very first bit. Now in a byte, the bits they increase from the right hand side. So the first bit is in this location, second bit is in this location, the third bit is in this location, the fourth bit is in this location. So this is how the bits they increase in a byte. Now suppose we have the first bit, so the amount of information it can store is either 0 or 1. So you can see like it's over here it's 0 and then it's 1. Now if we want to store more information, we add a second bit. So now whatever this byte stores is a combination of these two bits. So how does that work? So suppose we have a 0 here and a 0 here. So that value is considered to be a 0. But if we have a 0 here and a 1 here, so that value will be considered as a 1. Now if the second bit has the value 1 and the first bit has the value 0, that value is considered to be 2. And if both the bits have the value 1, that value is considered to be 3. Now moving forward, now what we do this time is that we add another bit. So now if we have 3 bits over here, so when all the 3 bits are 0, the value is 0. And now if all the so the first 2 bits are 0, but the second bit is the first bit is 1, so we get the value 1. And then you can see that we are shifting between these two values, 0 1 0 1 0 1 0 1. And as we go to the second bit, we get 0 0 1 1 0 0 1 1. And then when we go to the third bit, we get 0 0 0 0 and then 1 1 1 1. So last time in the previous slide, we stopped over here. When we have two ones, we get a 3. So the third bit needs to be a 0. Now for the value 4, we have the first two bits as 0, but the third bit as 1. And then we move forward. So again, the same pattern. So it's 0 1 0 1. We have 0 0 1 1, just like this. But over here, we have 1 1 1 1. And as a result, if you have the value 110, that is 6, you have the value 111, that is 7. So if we add the fourth bit over here, in order to get the value 7, we will need to have the first bit as 1, second bit as 1, and the third bit as 1. But the fourth bit will be 0, because if we put a 1 over there, that will become something else. So having a 0 over there, the value 7 remains intact. So that is how a byte stores the value, the numeric value in a computer. And we can also see that the values that can be stored increase in powers of 2. Now suppose if we want to have the value 3, we can write it as, so the first value will be 1, the second value will be 1. So we multiply the first value with 2 raised to the power 0, and we multiply the second value with 2 raised to the power 1. And now since we have 3 bits, we are multiplying the third value with 2 raised to the power 2. Now anything multiplied by 0 will become 0. So we can ignore this. And anything multiplied with a 1 will retain its value. So 2 into 1, this will become 2. And 2 to the power 0 is 1, so 1 into 1, this will become 1. So we get a 2 from here, and we get a 1 from here. We can see it over here. So this value becomes 0, this value becomes 2, this value becomes 1. So we actually get 0 plus 2 plus 1, and we get the value 3. And so you can see that we have 0 1 1, and that is the value 3. And we can look over here. So we have 0 1 1. For the value 3, we have 0 1 1, and you can see we get the value 3. So this is how the computer calculates the values. And now similarly, if we calculate the value 6, the value 6 stands for 110. So the first bit needs to be 0, the second bit is 1, and the third bit is 1. So we multiply the third bit with the value 2 raised to the power 2. This bit will multiply this bit with 2 raised to the power 1, with this 2 raised to the power 0. So this will become 0, this will become 2, this will become 4. So 4 plus 2, and we get the value 6. So this is how the computer does calculation. It arrives at the right answer. So now we are going to look into a small example. Where we are going to see like what will be the value. So we have this representation of a byte, and so the first bit is 1, the second bit is 0, third bit is 0, the fourth bit is 1, and then the seventh bit is the eighth bit is also 1. So if we look at the indices, so this is the 0th 1 2 3 4 5 6 7. In computer, the first index always starts with a 0, and that is true for Java as well. And now in order to calculate these values, we need to understand like these values must be multiplied with the powers of 2. So over here, since this is the 0th location, we have the power 2 of 0, then 1, then 2, then 3, 4, 5, 6, and 7. And these are the corresponding values. So if you multiply it, if you have 2 to the power of 0, it will become 1, 2 to the power of 1, it will become 2, 2 to the power of 2, it becomes 4, 2 to the power of 3, it becomes 8. So these are the corresponding values that we require. And now since the middle values, they were all zeros, we don't need to look into those because they will become 0 after multiplication. So the values we actually get are 1, 8 and 128, and all we need to do is add them together to get the output as 137. And so this is how you can see, like, it's very easy to convert a byte into a decimal number. Now, this leads us to the data types that are being used in Java. So we have a byte, which is used in Java, which it starts from the value -128 and goes to the value 127. We have a short, which is of 2 bytes. Then we have integer, which is of 4 bytes, a long, which is of 8 bytes, float, again 4 bytes, then 8 bytes, then boolean, which is 1 bit, and character, which is 2 bytes. So these are the literal values, the data type values that are being used in Java. The the common operators that we use in Java are plus, minus, multiply, divide, and this is the remainder. So for example, if you have 10 and you divide it by 3, you should get a 1. So if you normally divide it with a division sign, you will get 3.3333. But if you divide it by using a remainder sign, so you will get the value 1, because that is the remainder. For double, there is no remainder, but there is the plus, minus, multiply, and divide. You can do that. So this is used for floating point values. Now, if you want to ask, like, what is the floating point value? The floating point value is anything uh, which is hanging in between. So like 3.14. So it's neither 4, it's neither 3, but it's floating in the middle of the two values. So that's why it's called a floating point value. Then we have a boolean. Boolean is either a 0 or a 1. So and we have an AND over here and we have an OR over here. So if you know the truth table, so if you have anything AND, so if you have true on one side and you have true on the other side and you AND the values, so you will get the value 1. But if any one of those values is false, you will get the value false. And this is the NOT sign, which actually inverses the value. You will come to understand these once we go and look into conditionals. So we leave this at that. There are no operations which are applied to the characters. And string is a sequence of characters. You can see over here the character is like single a one character, this character, okay, and this is a special character. So you will understand like what this escape character is. We will come to know this in due time. Over here you can see that we have these examples. So these are the string of characters, like these are combination of characters. So whenever there is a combination of characters, you call it a string. So some terminologies that we should understand. So you will come across these quite often. A literal. A literal is a Java code representation of a data type value. For example, we use a sequence of digits such as 1, 2, 3, 4, 99 to represent the value of type int. So we just saw the literals. So these are the data types that store the value, and literal are these values that these data types store. Operator, we just came across this. So this is the operator, plus, minus, multiply. So if you have data and you want to perform some operation, so that is called an operator. Identifier. So whenever you store some data or you are going to perform some function or some action, you give it a certain name. So whatever that name is, that is called an identifier. So suppose you wanted to store like how many liters of data you are carrying. So you will create a data and you will start calling it water. So suppose you are carrying 5 liters of water, so you will put water is equal to 5. So that is an identifier which identifies like what value we are talking about. So right now I gave you an example like water is equal to 5. So water is the name of that data and it's normally called uh, an identifier, but an identifier can be of a function as well, so that you can separate one function from the other. So that's why it's called an identifier. A variable is a memory location which stores some data, and sometimes people confuse between the identifier or variable, but they can be used interchangeably. declaration statement. So whenever you want to create some variable which can hold some data, that is declared using a declaration statement. So for example, over here I have written double total. So this means like total is the name of the variable which is going to store the value double. So double is actually the floating point value, but which is has a very big size. Expression, like you any mathematical expression like this is called an expression. So you can write something like this to get some output. So any mathematical expression that gives you an output, so that is called an expression. So now we will look into the following code examples and see like how uh, how we can write a simple program which teaches us how to manipulate data, how to declare data, how to write data, and how to manipulate data. So now we move forward towards the code examples. Now we are going to look into a couple of examples which will give us a good idea about how the data types work in Java. So for this small example session or the code review, I'm going to use the Visual Studio Code which is written over here, and I'm going to use a Java extension to run my code in Visual Studio Code. I think the Visual Studio Code is a very good tool to run your Java programs, and I recommend that you guys use that. But you can use any Java program, IntelliJ or Eclipse if you want to. If you want to run your own Java programs, yeah, I have also told you how you can run your Java programs using command line interface. So if you are used to that, you can always use that. But right now I'm going to use the Visual Studio Code. Okay, so first of all, I have declared the name of the class, which in this case is example1. And in this example, as whenever you write a program, you need to have a main function. So I have declared a main function over here, which accepts some arguments, which I'm not going to use. But what I'm going to do is I'm going to declare three variables over here. So I write the integer a, comma b, comma c. So this is how I am telling the computer that I require three variables. All these three variables are going to store separate data. So now I write a is equal to 20 and b is equal to 100. So and now the variable c is going to be the value a plus b. So if I add 20 to 100, I will get the value 120. So then I use the output line. So this line only prints the output. So whatever the data I'll get over here, so it's going to print that as the output. So I've written the line the output is, and then I've written output is, and I've closed this comment, this statement, and then I have added to this statement the value which I will get from here. So it will say the output is 120. So now I'm going to run this program and see if whatever I have written is accurate. So over here I can click on run, and then this window pops up. I write run and debug, and over here you can see like we have the terminal which opens up, and I get the output is 120. So you can see like when I run this program, I got the output as 120. Uh, I can also write these statements something like this. So this is int a, then I can write int b, and then a semicolon. Whenever you are going to end a statement in Java, you always end it with a semicolon. In normal English, you use a full stop, but in Java, you use a semicolon. And I can write int c like this way. Okay. Another good practice is that whenever you are writing a variable, you put it equal to the zero value zero. Uh, so this helps in solving a lot of problems. So for example, if you cannot figure out like why your variable is getting the value zero, so that is probably because you declared it as zero, and but you forgot to add the real value of that variable later. Okay, so so suppose I forget to write the statement, and now if I write c is equal to a plus b, I will get the value 100, which is not the required value, and it will tell me, okay, so if I add b to the value a, why do I get the value b? So which means like a does not have any value, and so it's very easy to arrive at a solution this way, or problem a solution to your problem this way. So now I move on to the next example, and so this is example number 2. Okay, so uh, in this example we will learn to use expression to find the value. So you can see like over here I have written a command which is not which written a line which is not actually a Java command. So this is called a command. So if you want to write any line which conveys some information but uh, which is useful to you, okay, so you write it as a comment. So this is one way. You do two forward slashes and write the comment afterwards, or you can write the comment this way. So you write a forward slash and static, then you write the comment, and then you get a static and slash where you want to end the line. So now if we look at over here, we have a question. A car is moving with an initial velocity of 100 meter per second. It accelerates for 10 seconds with an acceleration of 2 meter per second square. What will be its final velocity? So this is a very simple example, and I have used Newton's first law of motion to first equation of motion to solve this problem. So over here we see that it's moving with an initial velocity. So this is going to be the vi. So vi is going to have this value. Acceleration is going to be a. It's going to have this value, and oh sorry, this is the time. It accelerates for 10 seconds. So this 10 is going to be the time, and 2 meter per second square is going to be the acceleration. So these are the variables or the values that we are going to use in order to arrive at our solution. So I have declared initial velocity as vi, and a, and time as t, and vf as the final velocity. So I have vi is equal to 100, a as 2, and t as 10. So I write vf is equal to vi plus at. So this is the example that we normally use. This is the equation we use to calculate the final velocity. So once this expression is calculated, the final velocity is acquired over here. So vi in this case is 100, a is 2. So 2 into 10, which is t, I get a 20, and 20 plus vi is 20 plus 100 is 120. So the answer again, in this case, the answer I will also get as 120. So the final velocity is going to be 120 meter per second. So I run this code again. Okay, sorry, not again. So this code is run the very first time. So I run this, run and debug, and it says the final velocity is 120. And you can see like I have used an expression, and this expression has led to me to this value. Now we look at the next example. So over here I have an example, uh, and this is about like using the println statement. So over here I have an integer value, I call it int value, give it the value 100, and then I have a string value. As I discussed before, string is a collection of characters. So I write string, which is str value, which is equal to John, and I write system.out.println string value, which is in this case is John, and then I add to that string scored, and then I add to that string the initial value. So John scored 100. So this is going to be the output. So I run this, and the output is John scored 100. So you can see like how we can use the println statement, and we can use the string value, and at the same time we can use the integer value. So println statement actually prints the value, prints the value whatever the value here over here as a string. So 100, or even though this is a numerical value, but when it is going to print the value, it's going to print it as a string value. That is the power of the println statement. So now we move forward to the next example. So this example is about converting a string to an integer and an integer to a string. So what this means is that whenever a value is written as a string, so that value is taken as to be as a character. So suppose you are you are traveling by bus, and the number of the bus is 50C. So in this case the 50 holds no actual value. It's not the numerical value 50. It's the number of the bus, and that is how you identify the bus. And then there can be any other bus as well that can be 52C. So that 52 does not mean that it's the bus number 52. It actually means is that this is how you're going to identify one bus from the other. So over here you can see like I have written string value as 120. So this str value stores the character value 120. So it's a series of characters of 1 is a character, 2 is a character, and 0 is a character. But Java gives us the functionality that we can convert this character into a integer value. And in order to do that, you use this function integer dot parseInt, and whatever the value is over here, you write it over here. So in this case, str value had the value 120 as a string value, but this function will actually convert this string value into numerical value. So 80 plus 120, we will get the value 200. So once we run this code, it will say system.println John's total score is 200. Uh, Now suppose you score 50, and for some odd reason there is somebody who's wearing a shirt number which is 50A. So instead of declaring so now what I want to do is I want to join this 50 with this A. So in order to do that, I have to convert this 50 into a string value. So in that case, what I will do is I will use again, there's a new function that I'm going to use. Whatever the integer value is, I want to convert that into a string, and so I pass that integer value over here. So this will convert this 50 into a string value. So 50 plus a, we will get 50a. So now if we print this out, it will say system.println John's shirt number is 50a. So why? Because shirt number is equal to this value, which is 50 plus a. So we will get 50a. So this will give us John's total score is 200, and this will give us like John's shirt number is 50a. So I run this code again. So not again, for the first time, and you can see like this is what we get. Now we move on towards the final example. And now we are going to look into the standard integer operators. So you can see like I have integer num1, num2, and answer. So I write num1 is equal to 10, num2 is equal to 3, and then I write answer is equal to num1 plus num2. So I write result of adding num1 and num2 is answer. So I add these two numbers, and I whatever I get, that is stored in the value in the variable answer. So 10 plus 3, I will get 13, which will be stored over here. And then 10, and I'm going to subtract 3 from here, so I will get the value 7 in this case. And then similarly, I will get the value of multiplication and then the division. Uh, and then finally the remainder. So now if I run this code, there's going to be an odd behavior you will come across. So you can see the result of adding is 10 and 3 is 13. Subtraction is 7. Multiplication, if you multiply 10 with 3, you get 30. And result of dividing 10 by 3 is 3. It should have been 3.33, but no, it's 3. So we will come back to this, like why this is giving us a 3. The remainder acquired when dividing 10 with 3 is 1. Okay. So uh, now if we okay, so now we come to the question like why am I getting a 3 over here? So the reason is that answer is basically an integer. Integer always are whole numbers. So you can have 1, you can have -1, you can have 0, but these are all whole number. It cannot have any number as a decimal value. If I want to do that, I need to have answer as float. So when 10 is divided by 3, I do get the value 3.33, but since answer is an integer, it will not store that value. It will store the whole number, which is 3, and it is going to reject the rest of the value. So uh, now what we do is we we run this small line of code. It says the result of dividing num1 with num2 is num1 by num2. And now we try to do this. Let's see what happens. And again we see that the division is 3. And this is happening because it's the this so because when it tries to divide, so num1 is an integer, num2 is an integer, so the output that it's going to get, it's also going to be an integer. So if I want to like get a proper output, I need to use type conversion. So what this means is that num1 is an integer, num2 is an integer. So whenever I divide, it's going to give me some value, and that value must be converted into a float value. A float, so this when you write this small line of code, so it converts the integer value into a float value. So since the result of this division is a float value, which is 3.333, I want to retain that value. I don't want the computer to get rid of that value. So now if I run this code, you can see that I get the result of dividing 10 with 3 is 3.33, and that is because I converted uh, the data into a float data. So this is and also you can see like over here I'm doing a division directly, so which means that I don't need to do this. So I can take this out, I can put it over here, I can take this out, I can put it over here, I can take this out, this part of the code, I put it over here, and then I take this part of the code out and I put it over here. Now once I do this, I actually don't need the answer variable. So I remove this, I remove this, I remove this, I remove this, and I remove. Okay, so over here I get remainder, so I have to fix this as well. And I use this. Okay, so once this is done, uh, am I missing over something over here? Um, okay, so it will probably tell me like what the problem is. Operator negative is defined in the argument string and int. Okay, so I think it's confusing these values, so I put these brackets over here, and now it should work fine. Okay, so this was happening because it was treating this entirety of this as a string, and since you can add some data to the string, but it was being confused by this negative sign. So whenever you are having such problem, you can put whatever you're doing in brackets, and it makes it simpler. Uh, so now you can see like I don't need this answer variable. I can do everything by removing this variable, and I get the answer that I require. And we can for aesthetics I have written it this way, but I can also write it this way and make it even smaller. So you can see like this is how you can write some code and get and manipulate data and get some output. And you can see like over here I have created a very simple basic calculator. and you can do the same. You can write the same basic calculator if you want. And I have just told you about variables, the operators that you use, and the different expressions that you can use to find the output. And so these five examples give you a very good start as to how to write your own programs. So what you can do, you can take up the Newton's second law of second equation of motion and try to solve that. You can try to solve the gravity equation if you like, and the computer is going to solve it for you. Just remember, you have to declare your variables. Oh, and speaking of which, you can also like reduce this further by writing int num1 and int num2. So you are now, this is called the inline declaration, so you can write it this way, and it makes the code even more smaller. Okay, so I hope that this small tutorial was good for you and you enjoyed it. Just keep practicing, just keep writing code like this, and that is the only way by which you can make yourself better. If you want to be good at programming, just keep on practicing, practicing, practicing. So now just go and make your own small programs and see like how you can use the computer to arrive at your solution. You can always pick up your higher secondary school books to write the programs and write something meaningful for yourself. So this is where we end this tutorial. I hope it was enjoyable for you, and we'll see you next time. Thank you.